All right, well, here we go. All right. I can't even do it. All right, everybody. Well, that sounds like a spooky haunted house thing. A do Markiplier. Hey, everybody. Oh, no, it's not working. It's just, all right, everybody. I'm Mr. Foster, and let's go ahead and get started. I have a lot of... Okay, thanks for the suggestions. I have a lot of different classes in here. I wanted to explain the hierarchy that there is so far, and then we're going to add to it. So first, there's a shape class. Now, shapes are kind of indistinct and don't really have many... They're kind of just there. They don't have many attributes about them. So I just gave a shape an instance variable for a name. The constructor just specifies the name. I made an accessor for the name. I did include area and perimeter methods because shapes do have areas and perimeters, but just for a basic shape, I can't really calculate the area and the perimeter. There is a very specific reason, however, that they're here, and we'll get into that a little bit later. Do you think subclasses of shape are going to use this implementation? Do you think I'm going to calculate the rectangle area by just returning 0.0? No. Probably not. So what am I going to do in a subclass? I'll probably override it. Very good. Very good. I'll probably override it. And then my toString just says shape. Then I said, oh, a specific type of shape is a polygon. Now, not all shapes are polygons. Circles, for example, are not polygons there. But some shapes are polygons. So I said, let's make polygon extend shape. And I added on a number of sides because polygons have a number of sides there. So that's the instance variable. You notice there's no mention of the name. Why? Well, because that's an instance variable from the superclass. I don't have access to it. So my constructor on line 28 goes ahead, it specifies the name of the polygon and sets the number of sides. The first line of your constructor in a subclass must be called to the superclass's constructor. My toString says this is a polygon with num sides. That's it. Notice it actually didn't call the superclass's toString method. It just says it's a polygon now instead of shape. Questions there? So far the hierarchy is shape up at the top. Well, the cosmic superclass object up at the top, then shape, and then polygon. Next, I did add on a class called triangle. A triangle is a polygon. So up at the top of the class header for triangle, you'll see it extends polygon. I said a triangle was defined by its two legs, leg 1 and leg 2. And I went ahead and I guess this is a right triangle class. Whoops, that's okay. That's okay. It's all right. So I made instance variables for leg 1 and leg 2. Here I said super triangle 3. First question, when I say super, whose constructor am I calling? Polygon, because the immediate superclass of triangle is polygon. Let's see what I'm sending to that constructor. I am sending triangle directly in for name, and I am sending 3 directly in for the number of sides. You'll notice that there's no parameters in the header for the name or the number of sides. This should look very similar the other day when you were doing that free response question for animal and herbivore and elephant. Didn't we do something very similar? Yeah. Okay. So we just say every triangle is named triangle. Every triangle has 3 sides. What would be the heckin' point of me putting, pardon my language, of me putting those in the parameters? Nothing. Every triangle is named triangle. Every triangle has 3 sides. There's no point in me making a parameter for that. It's just going to be redundant and useless. However, I did send in parameters for the leg 1 and leg 2 values. I specify those. Then I did make some methods. I made a hypotenuse method. Notice then in line 51 when I calculated the perimeter, I did leg 1 plus leg 2 plus the hypotenuse. If you're wondering why hypotenuse has parentheses after it but the other ones don't, well, hypotenuse is a method. Leg 1 and leg 2 are variables. I also went and found the area I used Heron's formula. I guess this is a right triangle, so I could have really used just base times height divided by 2. But I used Heron's formula, which works for any triangle. If you want to look it up, it's kind of interesting. And then, the 2-string. It says super. Which class is the super class? Polygon. So first it's going to do polygon's 2-string. So it'll say polygon with blank sides. In this case, it'll say polygon with 3 sides, obviously. And then a new line followed by the name. The name is triangle. I specified it right here on super, the super call. So it's going to say, polygon with 3 sides, new line, triangle with legs of length, whatever those legs are length. Does that make sense? All right. Just a quick review of the hierarchy so far, making sure we understand it. Up here we got shape, then we got polygon, and then we got triangle. Right now this is our whole hierarchy. A triangle is a polygon is a shape, a triangle is a shape. Make sense? Cool. We're going to write some extra classes on here. Now, I'm just going to say class instead of public class because, again, they're all saved in the same file, so it's kind of a necessity. So I'm just going to say class here, rectangle. Now, I'll make it bigger. Keeping in mind that hierarchy I just showed you, what should rectangle extend? What is a rectangle? Polygon. Polygon, very good. So I'll say class rectangle extends polygon. Now, let's kind of use triangle as a template for this one here. Next I do my instance variables. I don't need to worry about the name. I don't need to worry about the number of sides because that's going to be the same for every single rectangle because a rectangle is named rectangle and has 4 sides. What instance variables do I need? Width and height. Oh, you guys do width and height? Length and width? What do you guys like? Let's do a show of hands. Raise your hand if you do width and height. Raise your hand if you do base and height. Raise your hand if you do length and width. Length and width is what I did when I was younger. I don't think you're wrong if you say something else, but your teachers were. No, I'm kidding. I'm kidding. It's a joke. I know. Right now you're like emailing Miss what's her name now? Miss Reich. Or you're emailing Miss Bogren. Or you're emailing Miss Hansen, and you're going, Mr. Foster's talking trash, here's the YouTube link. No. It's just a different way of saying the same thing. Okay, careful. So much evidence out there on the internet right now. All right. Let's go ahead, a rectangle. Let's write the constructor. So we know that the first thing I'm going to have to do is call polygon's constructor. Polygon needs a name and a number of sides. Do I have to take that information in for rectangle? No, we know a rectangle is going to be named rectangle. We know that the number of sides is going to be 4, so I don't need that information. It's the same for all rectangles, just like the name of every elephant was, or the species of every elephant was elephant, they were all herbivores or whatever. What I do need to take in is values for the length and the width. And I know what you're thinking, is that an L or is that a 1? And then I know you're also thinking it's got to be an L because variable names have to start with a letter, not a number. Thank you for your honesty. It happens. Now, I could be, I don't want to say a dum-dum. I didn't say that. But I could do something like this. And then you're going to go, Mr. Foster, you didn't put super, so Java's going to go ahead and add super in there for you with no parameters. And then you're going to say, and that's a problem because there's no default constructor, so I do need to put super here. And if you don't remember what you need to send to the super constructor, you go to the super class polygon, you look, polygon expects n. I'm guessing n represents the name, and then an int ns, I'm guessing that represents the number of sides. So down here, I'm going to say super rectangle, 4 sides. Now we could add accessors, mutators, yada, 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 yada. That would be fine. But really what I'm interested in is stuff that rectangles can do. I think we can do a perimeter. We can do an area. Let's do those first. Let's start with perimeter. Everybody knows that one. That old chestnut. For a rectangle, it's like length, width, same over here, same over here. You could do L plus, okay, let's do the Winnie the Pooh meme where he slowly looks fancier and fancier. You could do L plus W plus L plus W, or this is like a galaxy brain. You could do that. You could do 2 times L plus 2 times W. And then if you want to go galaxy brain, you can factor out that 2. You do that. I know. Galaxy brain. So I'm just going to do the one that most people know, 2 times length plus 2 times L, or width. I'm not going to put L or W because L or W are only these temporary parameters. They're not the actual instance variables that I can witness and use, access, stuff like that. You guys are good with this? Area method. I'm having so much fun. We haven't done live coding together in such a while. It's fun. Area method. Here's a crazy idea. You could make a triangle that has the same length and width and find its area and multiply that by 2. Or you could just return length times width. You guys are no fun. Live a little, live a little. And another thing that a triangle can do, we've talked about before, there's like diagonals. So let's go ahead and make a method to calculate the diagonal here. Now, if you don't know, it's just like the Pythagorean theorem, essentially. You're essentially finding this value. The only difference is your polygon has a few more sides. But you're still just length squared plus width squared, square root of all that stuff. So return math.square root of the second power of length plus the second power of width. Is that a superclass of rectangle though? If you're to inherit it, yes. It would be like, trying to think. So like, let's say lizard and duck are different classes. A lizard maybe molts, loses its skin, while duck might lose its feathers. We couldn't just inherit molting because a duck's not a lizard, basically. Now, Julius, to go back to your question, if a rectangle was a triangle, then yes, we could use hypotenuse. Here's what, just really quick, if you want to know, Am and Stacy said, why don't we just do this? Why don't we make a new triangle, T, that has the same, that has the length and width as its, not us. Did my internet just cut out? Oh my gosh. Wait, if you look up on the big screen, I've got this yellow exclamation point, and I hate it. Wait, you still have my screen, though?
Yeah, we still have your screen.
My screen is frozen?
No, your screen's good.
What's frozen? Just the internet. Oh, we're chill, we're chill, we're chill. Let's keep going, we're good. We're good. Yeah, I have this too. That's unfortunate. No one. Shh. What? My recording thing is not on the internet. I'm not streaming right now. Don't worry. Don't worry. I know I should. I should really be on Twitch. It's more long form entertainment. Never mind. right. Here's what I want to do. Oh. We need a two-string method. Two-string methods always look like this. Public string, two-string. And what do we want this one to look like? Good question. What did I make it look like? Oh, okay. Let's do this. I'm going to kind of use the triangle one as a template. So I'm going to say polygon with 4 sides, new line, rectangle with length and width of width. I'll zoom out so you can get that whole line. So it's going to say polygon with 4 sides, then on a new line it's going to say rectangle with length and width of width. And I always need this header to look exactly like that for my two-string method. Public string, two-string. Okay, now the hierarchy has expanded. While you guys are finishing that up, it's going to be shape up at the top, then polygon, and then there's 2 subclasses of polygon at this point. There's rectangle, and there's triangle. So a polygon is a shape, a rectangle is a polygon, a triangle is a polygon, but a rectangle is not a triangle, and vice versa. And a polygon is not a rectangle, and so on and so forth. I think right now is a good time for a break. I can figure out what's going on with the internet, and then I'll explain the whole point of everything here. So, all right, everybody, we're going to add one more class called Square. Taking in mind our hierarchy, what should Square inherit from? Why is there only like 2 people saying it? I gave you the thing, you. All right, yeah, you, okay. All right. Now, serious question. What extra instance variables do we need for square? I don't think we need any. Because a square, since a square is a rectangle, doesn't it have a length and a width? Yeah. So I'm not going to add any extra instance variables. What I will do is write a constructor. If you guys don't understand that, remember you inherit any private instance variables. So we have a length and a width. That's what a square is, a rectangle with a length and a width. It's just the difference is the length and the width are going to be the same. But I don't need to make an extra instance variable for that. I already have a length and a width as a square. How many parameters should we take in? I'm leaning towards 1 because it's going to set the length and width to the same value. Does that make sense? All right, now if you look, okay, you guys know this. The first thing we have to do is call the superclasses constructor. If I just leave it like this, it's going to call the superclasses default constructor. There's not one, program crashes. You can go ahead and see. Bah. Constructor rectangle and class rectangle cannot be applied to given types. It requires a double and a double. We sent it nothing. Okay, so I need to say super. And if you look at that constructor, it expects a length and a width. What am I going to send it twice? Side length or whatever you named your variable, your parameter, I should say. Could I just say rectangle there is what you're saying, or?
No, because it's a square. I get squares are rectangles.
Yes.
But shouldn't, because it's a certain rectangle, shouldn't we name it square?
Courtney is totally right. Courtney, I made this hierarchy and then that came up last time. I was like, ugh. I'll show you how we're kind of gonna fix it a little bit. But yeah, Courtney's saying, well, up here, this is making our name rectangle, and now basically, since I'm 2 layers deep, I don't have any access to the name. You're right. Dang. So here's what I'm going to do to kind of fix that. I am going to write a one more thing. Do we need to write an area method? We've already got from where? Rectangle. And is the implementation the same? Yes. What about perimeter? Yeah, what about diagonal? Yeah, they're all the same. I don't need to rewrite those unless you're going to write public double area return super dot area. You already have that method. It's like it copy and paste it in inheritance. So instead, I'm just going to add a toString method because Courtney's right. My toString is going to be totally bonk right now. It's going to say it's a rectangle and stuff like that. So, Courtney, here's what I'm going to do. And everybody else, here's what I'm going to do. You might not like it, and that's okay. I'm going to add on this is also a square. There you go. I apologize to everybody. There's probably a better way to handle that, but there it is. Now, ideally, you know what I would probably do? Just make a mutator for the name up in Polygon, and then just change it that way. Because I didn't inherit it. But right now, I'm kind of it didn't work. I'm not going to use any inflammatory language on YouTube anymore, especially not towards baskets and weaving and stuff. All right. So this calls rectangles toString method and then tacks on a new line. This is also a square. All right, now we get to do the stuff with it. Ready? I am going to add the thing that we're trying to get to. I'm going to add one more class called tester. You know what? Don't call it tester. Call it shape tester. That's better. It's not going to inherit from anybody. This is my tester, my client method. It just has or client class. It just has a main method. Whoa. Yes. Yes. All right. I posed this question the last hour, and I will do whatever you guys want. But we are going to make a collection of shapes, kind of like what we did yesterday. Do you want to do an array list or an array? Oh, okay. Array list. Now, if I'm going to use an array list, I believe I have to import. I wonder if I can do it right here. Let's see what happens if I do it right here. I'm just curious. Well, let me do that. Please don't complain. You son of a gun. Okay. This has to go all the way at the tippy top. So sorry. I know you're like, I knew that. Okay. I'm going. There we go. It's java.util.ArrayList. Util is short for utilities. The number of times I see java.until, it's too many. Java.util.ArrayList, capital A, capital L. I'll give everybody a second to make sure they have it typed exactly like that up at the top. You could do java.util.asterisk as well. The only issue is then you're going to import a bunch of classes you don't necessarily need. But you could do that. All right, you guys got this? Good. Back down here to main method. Here we go. A quick review of how to make array lists, since we haven't done that in a while. We write the word array list. Anybody remember what's next? The thingamabob. I know what you mean, the alligator bracket. I know what you mean, the alligator bracket. Now, if I want to put shapes, polygons, rectangles, squares, triangles, all in here, what should this array list hold? You guys are so good. Nice job. So I'm going to say the type that's going to hold is shape. I'm going to name this array list shapes. And then to finish, you go over here and do pretty much the same stuff. In some ways. Now, just a reminder for everybody, if we were dealing with an array instead, I would have to say something like shape, square brackets, shapes equals new shape, and then however many I want it to hold or something like that. That's how I would do it with an array. But we ain't doing that. We're doing it with an array list. Right now, how big is the array list? It's got nothing. It's got nothing in it. So I'm going to go ahead and add some stuff to it. Let's add them in order. Let's do a shape first. I'm going to use the anonymous object, just create one really quickly and toss it in here. I think that's pretty common with array lists and arrays because you don't really need to know their name after you add them. You can reference them now. They're in the list. So it's kind of common to use these anonymous objects, just calling the constructor and throwing them in immediately into an array list because now they have a name. They're in shapes. It would be shapes.getZero. The shape constructor does need a name. I'm going to call this basic shape. And remember, is that legal? A shape is a shape. So that is legal. I've said the word shape so many times today, it's just lost all meaning. What's next? Polygon. Let's do a polygon. What? Shape, shape, shape. It's like, have you ever seen How I Met Your Mother when he's like bowl, 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 bowl. It just loses all of its meaning. And shape is a really weird word. I've lost the track here. Oh, give it a name. I'm going to just call it basic polygon. And then the constructor also requires the number of sides. I'm going to give it 0. I know what you're saying. Some polygon, Mr. Foster. 0 sides. Okay. I know. I thought poly meant mini, not 0. Yeah. Okay. Let's go ahead and add the next one. Let's go triangle. If you remember what triangle was looking for, it didn't need the name, it didn't need the number of sides, because all triangles are named triangle and they have 3 sides. It does need a leg 1 and leg 2. I'm going with 3 and 4. Everybody's favorite. What's your favorite Pythagorean triple? Oh, that one's pretty good too. People are into the 3, 4, 5, I think. A lot of 3, 4, 5ers out there. Let's see, what's next? A rectangle? Rectangle needs a base and a height. And I'll go ahead and make a square. What side for my square? I don't know. How about 2? Geez, I haven't compiled in a hot minute. All right, there we go. Now, some things you can do. We can print out the whole array list. Now, array list does have a toString method. Array list toString method looks at every element in your array list and prints out its toString, or whatever its string value is. So if I go ahead and print out shapes, unlike when I try to print out array, I'll actually see some data here. Now, I'll admit it's kind of hard to follow. Let's see. Let me see if I can maybe diagram this out for us. Hold on. There. Scroll up. Oh, perfect. Okay. So this one, shape. That just comes from the toString of this guy. Polygon with 0 sides. That's the toString of this guy. Okay, this one's a little tricky. Polygon with 3 sides and triangle with legs of length 3 and 4.0. That comes from this guy. This next one, polygon with 4 sides, all of this stuff here comes from this guy. And then I don't have another color, so I'm using red again. This last part, this last part over here, this comes from the square. You can tell because on the end it says this is also a square. So why do they all look different? All the toStrings look a little different, huh? Why? This is the idea of today's lesson. You can click on it or you can read along with me. I'll just pull it up here. I've got it right here. No, I don't. I've got it right here. Polymorphism. Let's break down the word. Polymorphism is a big word that you can break down into poly, which means many, and morphism, which means form. So it just means many forms. How many different two-string methods were there? There were many different two-string methods. Were they all the same? No. There were many forms of the two-string method. This is an example of polymorphism. In Java, it means that the method that gets called at runtime when the code is run depends on the type of the object at runtime. So when it goes through and it looks at this object right here, it goes, what constructor were you made with? You were made with shapes constructor, so I'm going to print you out using shapes two-string. Then when it prints out the next element, it goes, which constructor were you made with? Your actual type is polygon because you were created with polygons constructor. I think you guys took notes on this yesterday. This one, its actual type is triangle. It was created with triangles constructor, so whose two-string is this going to use? Triangles. And the same for rectangle and square. The two-string method takes on many forms. What other methods did we write that take on many forms? Area. What else? Let's start with area. Let's say I want to loop through and print out the areas of all the shapes. Check this out. You guys ready for an enhanced for loop? Good. Here we go. For. What are the types of objects that are in shapes? Shape. So I'm going to say for each shape, and then you can name it whatever you want to. I'm going to say S. For each shape S in shapes. So if you don't remember how enhanced for loops work, it's going to take this element, stuff it into S. Then it's going to take this element, stuff it into S. Take the next element, stuff it into S, one after another after another. So I can print out okay, two things before I go ahead and run this. I'll let you finish typing it. But I am allowed to call area because I'm guaranteed that everything in the array list has an area method. How am I guaranteed that everything in the array list has an area method? Because I wrote it in shape. Since I wrote it in shape, Grim, are you winning?
Yeah.
Good. Since I wrote it in shape, either the subclasses of shape will either inherit it, or maybe they've also, instead of inheriting it, they might have overridden it. But I'm guaranteed that every shape type object has an area method because the area method is in shape. If you remember right at the beginning when I was going over this class, I said shape has an area method that returns 0.0, but we're probably not going to be using that implementation. We're probably going to write our own method body and override it. But since shape has its own area method, I'm guaranteed that any objects that are a shape, any objects that have the is a shape relationship will have an area method. I can override those. I'm guaranteed that they all have a area method. So if I run it, now you'll see that they all calculate their area a little bit different. Why and how do they calculate their area different? Well, let's look. This first one was a polygon. Or excuse me, the first one was a shape. What's the shape's area method return? 0. That's why you see 0.0. The next one was a polygon. Did polygon have an area method? No. So where does it inherit it from? Shape. So we see 0.0. Next, this one's 6.0. That's not 0.0. Why? We overrode it, however you want to say it. We overrode it in triangle. What about this one here for rectangle? We overrode it, however you want to say it. We overdid it inside a rectangle. And then in square, well, square doesn't have an area method. Where does it get it from? From rectangle. So this is an example of many forms. You want to see, here's what polymorphism means. You ready? Polymorphism means this. You have an area method. You have an area method. And you have an area method. It's the same method with just different forms, different ways to calculate it, but you're guaranteed every shape has an area. What else could I put inside of this loop instead of finding the area? Perimeter. Because I put the perimeter method inside of the shape class, I'm guaranteed that every shape type object will have a perimeter. You go ahead and run it. You see that the perimeters are all different. Where does the perimeter 0.0 come from? Which class does this method implementation come from for this first one? Shape, the next one? Shape because it's inherited in polygon, this next one. Triangle, this next one. Rectangle, this next one. Rectangle, square inherits it from rectangle. So this is the idea of polymorphism. It's the same method, but it takes different forms inside of those subclasses. But I'm guaranteed that they're all going to have a perimeter method because if you don't remember, here's the hierarchy. And then we've got several different classes down here. We've got rectangle, we got triangle, and then I got square down here. Since shape has a area method and shape has a perimeter method, I'm guaranteed that any of the subclasses will have an area and perimeter method. Now, whether they use the implementation from shape or if they override it in any of the subclasses, that's fine. How am I going to know which method implementation to use? How do I know to use rectangles area method versus shapes area method? How do I know to use triangles perimeter method versus polygons perimeter method? Very good. It always depends on this. What constructor were you created with? What? Say it again? What did I?
No, that's according to the class.
She's doing such a great job. I mean, like, what am I doing over here? Who knows? I'm just like pointing at stuff while people play, I don't know, Agario. Now, what is something I can't put here? What happens if I go ahead and put diagonal? I want to explain why I can't put diagonal. If I go ahead and compile it, it says it doesn't have diagonal. Now, many of you understand, okay, well, it's because shape doesn't have a diagonal and polygon doesn't have a diagonal and triangle doesn't have a diagonal, right? Not exactly. The reason I can't put diagonal here is in polymorphism, when you declare your object, basically we've declared all of these to be a shape. You can only use methods that exist in shape. So I can't put diagonal, not because it's not in triangle or polygon, but because my array holds shapes. Only methods in shape can be used inside of this for loop. I could do something like this, though. You ready to have your mind blown? I could do something like this. If S, I think this will work. If S instance of, which one has diagonal? Rectangle? Then what I think, okay, hold on, give me a second. I think this will work. I can cast it as a rectangle. Hold up. Don't worry about it. So we went over the instance of operator a long time ago. Basically, I'm saying if the shape is an instance of rectangle, which two are rectangles, this guy and this guy, then go ahead and find the diagonal by casting. Well, this is not part of the lesson. I just want to show you that it's doable. I'm basically casting it to a rectangle type, which means I can use any of the methods that are in rectangle. And it only works for the ones that created with rectangle or squares constructor. What's another method I can't use? Diagonal, we said. What's another one? Hypotenuse. Why can't I use hypotenuse?
Because it's declared in shape, and shape, it's not like made in shape.
That's exactly right. Since it's not in shape, I'm not guaranteed that all of these are going to have a hypotenuse method. Does that make sense? Okay. This is the idea of the whole lesson, polymorphism. You have the same methods, whether it's two-string, that's the most common polymorphistic method that you can have because it looks different in most classes. And you basically override it because you're all objects. An object has its own two-string. So that's the most basic polymorphistic method we use is two-string. But then in this example, area was polymorphistic. Perimeter was polymorphistic because it looked different depending on what class your object was created as. Does that make sense? If you go back to remember when we talked about mammals and giving milk? It was a long time ago when we started this unit. So you might have a give milk method in mammal, but it's probably overridden and takes many forms. I learned last hour we looked, a whale has nipples that are inverted when it's going through the water, and then when a child comes up against it, then it gets uninverted so the child can feed. Humans obviously give milk in different ways. Duck-billed platypus sweat out their milk. And so there's a lot of different ways to give milk. That's another example of polymorphism. There is an assignment that is 5 questions long. Let me show you what it is. Homework, do the attached assignment on a separate sheet of paper. Add Google Drive, hit me with it. It is 5 questions. You might have to refresh the page. It'll come up in a second here. It's 5 questions, but it's kind of long because there's a lot of classes and subclasses going on here. Oh, this should say flute. Flu. This should say flute. Don't worry about it. There we go. So here's the assignment. It's 5 questions. 5 questions with a bunch of classes. You're thinking about polymorphism. If anything gave you a hard time today, you could watch the video, of course. Then you'd have to listen to my voice again, which is like, I think it's in the Geneva Convention that that's not allowed. But you could do that. You could go back and look at the CS Awesome lesson as well on polymorphism. But the whole idea is that methods within an inheritance hierarchy can take different forms. You can inherit them, you can override them. You always use the form of whatever type of object you are. 5 question assignment, do it on a separate sheet of paper. We'll check it tomorrow.